Okay, so go ahead now and please title your paper Discovery of Seafloor Spreading, because this is the idea where they realize that the seafloor is actually spreading out. For the continents to be moving apart, the seafloor is actually getting larger. It's spreading out. That's what's going on. It isn't just that the continents are floating around. What's happening is that new ocean floor is forming between them and pushing them apart. Or the force that is actually making a move, that's what we're going to get into later on. So title your paper, Discovery of Seafloor Spreading. If you need more time to write down anything that's in white, just pause the video, okay? If it's white, you got it right. So go ahead and write that down as the title. And here's the deal. There was a bunch of evidence that they came up with after World War II. All right, the first one is when they started being able to map the ocean floors, when they had the technology to do that using depth finders. It turns out that the continents don't really end at the coastline. That's just where the water happens to wash up on there. The continents are these slabs of granite floating around on the basaltic mantle. We'll get to that later on. But there's a continental shelf. It turns out it's about 100, 150 feet deep, and as you go off the coast, then it drops right down to about 2,000 feet. And it turns out these continental shelves, these underwater edges of the continents, actually fit better than the actual dry land boundary of the continents. So the continental shelves fit even better than the land masses do. So that's the first piece of evidence they started coming up with when they could map the ocean floor. Okay, Harry Hess, this guy, write his name down. This guy here is the person who came up with this theory. Now, he was a captain in the American Navy in submarine warfare during World War II. And he came up with certain, technologies of trying to use sonar and depth finding and things like that to find enemy submarines. And then also being able to map the ocean floor and know what the depths are and things like that. They came up with new technologies to be able to map the ocean floor. Then after World War II, he became a professor and continued working on these particular kinds of discoveries he was making while he was really engaged in anti-submarine warfare during World War II. So there he is in the U.S. Navy, Harry Hess. All right. So what happened after World War II, they started being able to map the ocean floor. It wasn't just submarine warfare with the Germans, but also, I don't know if you're familiar with the Cold War, where you had, submarines from the Soviet Union and the Americans being in kind of a certain amount of, let's say, geopolitical conflict. Well, anyway, to be able to map the ocean floor and understand it was a good way to help America be able to work anti-submarine surveillance and stuff like that with the Russians. So they made this project where they go back and forth and back and forth and back and forth across the ocean, mapping the depth of the ocean. And it turns out in the middle, right smack in the middle of the ocean, there's a mountain range called the Mid-Atlantic Ridge. Okay, so when they do the how the radar or sonar, works, they'd make like a ping and it'd be like ping, and then it would bounce off the ocean floor. And the longer it takes it to reach back, the deeper it is. So using depth finding gauges basically to map the ocean floor. And they discovered there's this structure right in the middle, smack dab in the middle of the ocean, equal distance from North America and Africa. And take a look at this. Here's the continental shelf, which mirrors the continental shelf of Africa. And look, it's almost like a zipper goes down through the middle of the ocean. That mirrors that exact same shape. And when they discovered that, people were like, well, maybe coincidentally, you could have the coastlines fit together, but there's no way you could have not just two things fit together, but three things fit together. Okay, so what's going on with this Mid-Atlantic Ridge? That's what they started wondering, the geologists started wondering about. Okay, so go ahead and write this down. The Mid-Atlantic Ridge goes right down through the middle of the Atlantic Ocean. That's why it's called that, and it's a ridge. They discovered that this is what's called a divergent boundary. That means that the boundaries, these two slabs on either side, are moving away from each other. They're diverging, which would mean, since on those slabs you have Africa and South America, they're moving away from each other. You see what I'm saying? So please write this down. The Mid-Atlantic Ridge is what's called the divergent boundary. And then there's other boundaries we'll get into next lesson called convergent boundaries, where things come together. And I'll get into that later on. But right now, let's just talk about divergent boundaries. The first one discovered was the Mid-Atlantic Ridge. Okay, now around the world there are different underwater ridges, and each of these are divergent boundaries where the plates are actually moving apart from each other. There's one down here in the Pacific Antarctic. Juan de Fuca, right off of Washington State. You've heard of the Strait of Juan de Fuca. We have the Juan de Fuca Ridge. We have our own little tectonic plate over here. We're going to be revisiting that in future lessons. But here's the Mid-Atlantic Ridge. Look at that. It goes almost all the way across the ocean. And notice how the shape mirrors the shape of the coastlines too, right? Okay. So anyway, what's going on in the Mid-Atlantic Ridge? It's really deep. We're talking about 2,000 feet deep. And so they started coming up with submarines that could actually go all the way down there. Some had people in them, some did not. And they'd photograph what's going on. And they'd find these structures down there that's called pillow lava. It's like a lava that's, well, it's shaped like a pillow. That's why it's called pillow lava. Now let me show you this video of pillow lava being formed, because the only way pillow lava can be formed is if lava gurgles to the surface underwater. It quickly cools off and it forms these pillow shapes. So here's a video coming right up here about pillow lava. Now here's a video of pillow lava being formed. Now this is what happens when lava comes to the surface underwater, right? And the outside part of it freezes faster than the inside part, and so it forms these pillow shapes. Now what that means is that what you're seeing here is the formation of new ocean floor. And so please write down, pillow lava shows that magma is coming to the surface of the ridge. So what it's showing is that new seafloor is being made. When the lava comes to the surface, that becomes brand new ocean floor, right? And so there's new seafloor being made at these mid-Atlantic ridges, which happen to mirror the coastlines, right? So please write this down. If it goes too fast, pause it and write it down. Pillow lava. Okay, so anyway, you find pillow lava at these mid-Atlantic ridge and other ridges as well. And here's an interesting thing. Check this out. This is in the most volcanically active place on the planet. Anybody, you know what it is? This is Iceland. Okay, so anyway, notice the mid-Atlantic ridge. Here's Iceland up here. The mid-Atlantic ridge goes right through Iceland. This is why it's so volcanically active, is because it's right on the ridge. That's where new ocean floor is being made here, but here it's come up to the surface to make the island of Iceland. And so they have volcanic eruptions all the time there. And this is a particular kind of lava called basaltic lava. It's the same kind of rock basically that the ocean floor is made out of, basalt, okay? Our continents are made of a different kind of rock called granite. Well, Iceland is just like the ocean floor, but it's higher up, and it's new Iceland is being made. Well, so is new ocean floor. So Iceland lays right on the ridge. You don't have to write that down. I would love to see one of these volcanic fountains.